Hi everyone, my name is Preshayla and today we're going to be going through an example question on the topic of lenses. It's from the AQA exam board and it's a GCSE Physics question. This question is all about convex lenses. The first part of the question asks, what are convex lenses also known as? Well, convex lenses are also known as converging lenses. I like to remember it because they both begin with the same four letters. In the same way, concave lenses are also known as diverging lenses. Convex lenses converge all the light into one point. Concave lenses diverge the light. We then have a diagram of a convex lens. The principal axis has already been drawn for us. We need to construct a ray diagram to show how the light would behave when it enters, goes through and leaves the diagram. We also need to label the focal length. So we'll start by drawing four parallel rays of light going in to our lens. Then we need to show what happens to the light as it leaves the lens. So we know that because it's a converging lens, all the light goes to a single point, which we can show by joining each line to one single chosen point. It can be any point of our choosing, just so long as that all the rays of light go to the same place. So now that we have our rays going to the focal point, we then have our rays going back out of the focal point. Now the point where all the rays meet is also known as the focal point or the principal focus. They both mean exactly the same thing. So this is a really key part of any ray diagram. The focal point is a really key part because it helps us to understand what the focal length is. So we've been asked to label the focal length. The focal length is the distance between the centre of the lens and the focal point. Now, the third part of the question asks, what are some applications of convex lenses? Well, we see them in the world around us, in glasses, in magnifying glasses, in microscopes, in cameras, and even in our own human eyes. So they're really important, and it's really important that we know how to construct a ray diagram for them, as well as being able to generally construct a ray diagram because they can come up in many different scenarios with many different examples.